Hi, GI. Hello, can you hear me, GI?
Uh,
Hello, yay, success. How are you keeping? Are you okay?
yeah, I did my physics test today for the end of the year, and I actually found it
Oh
quite
my
yeah.
days, physics was today. How did it go?
It was really easy. Like I expected it to be so much harder.
Yeah.
And there was a few, I guess there was one six marker, and it was on the circuit experiment with the like the filament lamp and the
Yes.
current and resistance.
Okay, and so you have to draw a circuit diagram there.
No, it was about the method and steps. So I think that was
Okay,
not that
the
bad.
method and the steps. Okay, I see. And this is to find the IV characteristics of a filament lamp, is it?
Yeah, it was like yeah, it was about this method and how
Yeah.
they could yeah.
Okay. And did you write that out in terms of bullet points, or did you just write it out in sort of like a single prose essay style?
Oh, I did it in bullet points.
Very good. Very, very good. If you do that, okay. And of course, one of the things that you always get marks for is make sure that you mention that you have to repeat.
Yeah, I said that as well.
Very good. Excellent. 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 That is exactly. So I think you got quite a good number of marks there. Good. And how long was the paper? An hour?
It was 45 minutes, and I would say it was mainly equation based, and there was one
I
question,
see.
the how increasing the volume of gas in a syringe would decrease the pressure, and I think that was quite easy question to answer. I found it quite easy, I guess,
Good. Good.
overall.
Had you seen any of the questions before, say from the previous homeworks I've given you and such?
Yeah, and also I did a few past paper questions, so it all came up quite a bit.
Good,
So it
good.
was quite
Always
nice.
helpful. Excellent. And it's really good because what we've been doing, RGI, is we've really been working on the higher end of the questions, grade 9, grade 8. So I'm hoping you're beginning to appreciate that it does help then, because if you've been performing at that level, when you go into your exam, it's much, much easier. You won't find it as challenging as, say, if we'd been mostly focusing on grade 7 type questions. So that's the capability I want to build, because obviously, from what I see, I see, and correct me if I'm wrong, but I see that you're quite, you have great ambitions in terms of where you'd like to go for A levels and university as well, isn't it? So
Yeah,
in that case, then I'm building capability for the future as well. I'm not just
yeah,
building capability just for these end of year exams, but in the future, the strengths when you go on to do your advanced levels and when you do go to university as well. Cool. Awesome. When is your maths test then?
I did both of them, the non-calculator and calculator paper, and I would say the calculator paper was quite easy. It was easier than the non-calculator actually.
Right.
Yeah,
And you've so all the maths is out of the way then.
yeah, all the science and math are out the way.
Okay. So how did you do it? Did you have one non-calculator paper for 45 minutes and then another calculator paper for 45 minutes?
Yeah,
I see, I see. But you obviously don't have any marks for those tests you've done.
no,
No, okay. No problem. No problem. It might be a few weeks before you get them, unless your teachers are as efficient at marking as I do. Because normally when if my students do a test today, tomorrow they'll have their results. Because yeah, that is how I mark, because I know that they're equally excited. They want to know their result, because I was once a student and I know that once you're finished, the sooner you can get your result, the better. All right. So what we're going to do, like I said, we are building capability for the future here. So you have done your test anyway. These questions are all non-calculator. Now, why have I decided to try and focus on some non-calculator questions? Because some people can be very good at using their calculator, but what lets them down is the non-calculator paper, because they haven't quite honed their mental arithmetic skills to the same degree. So what we're going to try and do is start building capability in that regard as well. We're going to be looking at some challenging questions, so I'll be very frank with you, but that's not different to what we normally try and do in any session anyway. So we have these two first questions, and I want us to look at, we want to strengthen our understanding and our application on surds. How are you with surds?
um, I think I got better after the exams, but before that, it was kind of not really
Not
good.
okay. So have a go at this, and I want to see how solid you are with surds. And the questions are going to get progressively harder, okay? But from each one, especially from the harder questions, you're going to learn a lot of tricks. That's the whole aim of this game. Try and learn as many tricks as possible, which you can have in your bag. So when you're ready, have a go at number one.
For number one C, C would be two, I guess.
So what did you get?
I got 2.
So you got 2 root 2. Well, you've done it very fast. Very, very fast. So you squared A.
Yeah. So it'd be 8 plus 4, and then 8 take away 4, and then I just made it into a surd.
Yeah. So root 8 plus 2 squared gives you what? Gives you root 8 squared plus, remember that trick I told you? The middle term is going to be 2 multiplied by this, multiplied by that. Yeah. So 2 times 2 is 4. Sum of the term will be 4 root 8. And the last term will be plus 4.
Oh, I kind of did it like just 8 plus 4.
No, you can't do it. There's a middle term you're timesing, so you've got to use your FOIL here. It's 2 brackets multiplying to each other. Okay?
Yeah.
So this won't be right. Do you want to revisit the problem again? Yeah. Good.
Would it be 16?
16, just 16,
root 2.
16 root 2, correct. Absolutely. Well, C is an integer, much better. And so for 4 marks, you have done that question. Good. Okay. So just don't be tempted just to square them individually. Remember that you're expanding the whole thing. Excellent. Number 2.
Would it be 2 plus 4 root 2?
So what did you get for that one?
2 plus 4 root 2.
2 plus 4 root 2. Excellent. Nice and easy or straightforward. Well done. 2 plus 4 root 2. So looking very strong. Very good. Next one. Again, all these are non-calculator.
Yeah.
One moment here. I'm just going to use the toilet very quickly. Literally, I arrived like 2 minutes before the start of the lesson. I had a meeting at school. So I've not had time to take off a tie or anything. I will be with you literally in the next minute or so. Is that okay? Are you nearly at the end of finding this one, or are you still in the process of working it out?
Not really. Not really. I'm on this kind of like, yeah, I'm working out this volume right now. So
Okay, cool. I'll see you very shortly. Thank you. Okay, I'm back, yeah.
Yeah, I got B.
Well done. Smashing. That is very well done. Good. Next one. Actually, while you're still in surge mode, we're going to come back to this one. Don't worry. Let's go for this one here, number 7. Because we still want to focus a little bit more on surge. Again, the unknown calculator.
I'm actually not really sure about this one. Like, yeah. Right.
Here. So if you drawn in a few construction lines, it says what is, so it says the ratio of the length PQ to QR is 2:1. It says what is the radius in centimeters of the circle? So a rectangle PQRS is drawn inside a circle with its vertices. Would you agree that the center then would be in the center of this rectangle?
Yeah.
Okay. The area of the rectangle is given.
Yeah.
And we've been given what the ratio of these two sides are. So if this side is X, what should this side be?
2x.
2x. So can I work out what X is with this information?
Yeah.
Is that what you did?
Oh, I worked out the line crossing the center.
Good. So we've got a line crossing the center
Mhm.
from there, which will be the radius.
Yeah.
That's the radius. So did you work out what this length is?
No, not really.
But can you now see that you're able to work it out from these? You can form an equation using this information and work out what X is.
Yeah.
So you're happy to try and work it from there?
Yeah.
Good.
Oh, no, I got 8. I got 8.
But
But
8 is not there, so we've gone wrong somewhere, haven't we?
Mhm.
So when you come here now, just to look at this, so QR, yeah, PQ to QR, yeah, that's fine. So did you say then 2x, because the area is length times width, so 2x squared, because it's 2x times x, is equal to 96. You divide by 2 on both sides, so you get x squared equals to 48. And therefore, what is x? X is the root of 48. And what's the root of 48 if we simplified it in surds?
4√3.
Is it 4√3?
Yeah.
So what did you split it into? So you have 16
Yeah.
times 3. That's fine. Root of 16 is 4. And you're absolutely right, 4√3. And so this is 8√3. We need to find that here. Well, what can we see here?
I guess you can do like Pythagoras.
Correct. Is that what you did?
Yeah, but I kind of went a bit wrong with the 4√3. I got 4√2, so I got
So
the
what is
rest
this?
of them.
What is this length here?
Oh, it'll be half 4√3.
Thank you. Half of that, which is 2√3. And what is this length here?
It'll be half. It'll be 4√3.
Is that what you had?
But yeah, but I got 4√2 instead of 4√3, so I got the rest of them a bit mixed up.
Okay, so now with these values, what do you get as your final answer?
Would it be 12F? So be F.
Are we sure?
Yeah.
2√3 squared plus 4√3 squared. This will be equal to r squared. Yeah?
Yeah.
So if I square this, what do I get? 2√3 squared. What does that give us?
That will give you 6.
This gives me 6. Are we sure? Think about it. So this here will square, and this will square, and I'll multiply the 2 together. 2 squared is 4. √3 squared is just 3. So the answer to 2√3 squared is 12. You following that?
Yeah.
What is this one squared?
80.
Good. I have 18 plus 12. No, 6, that gives us 30 equals r squared. So what does this give us as our r? Well, r is the square root of 30. And what's the square root of 30 going to look like if we had to break? Can we break this down into something that can be
It would be 5 and then 5√5? No.
not quite. Hang on, this can't be 18.
Yeah, I said 80.
Sorry?
Is it 80?
80.
Yeah.
Hang on, this here is a √3. So if you square √3, you get 3. If you square 4, you get 16. 16 times 3 is 48.
Yeah.
Yeah, so we have to absolutely watch it there. 48 plus 12 gives us 60. Now we're finding the square root of 60. So square root of 60, which of these is the same as the square root of 60?
2 root 15, so D.
Thank you. Now, a lot to learn from here, especially when you square surds, because you went wrong there when squaring a surd. You have to square each of these individually and then multiply them together. Likewise, if this was a cubed, you would cube that and cube this and then times them. Are we okay with that?
Yeah.
Super stuff. Okay, now we can change gear a little bit before, but again, it's all non-calculator. Okay, straight lines.
I'm not really sure about this.
Okay, that's fine. The whole point is we want to be, we want to be doing challenging question. Why is it saying screen share? Okay, so, here we go. The line joining the points with coordinates p, p minus 1, and 1 minus p, 2p is parallel to the line with equation this. The first step here, we need to know what the gradient of this line is. What's the gradient of this line?
Y equals mx, so 3.
Not quite. So for a straight line, the equation is always y equals mx plus c. We always have to rewrite it in this form. The y should be on its own before we can say what the gradient is. The equation has to be made to look like this first. So if I do that, what's that going to give me? Well, I'm going to take all these things to the other side first. And I'm going to have 3y equals to minus 2x minus 1. Then I divide everything by 3.
Yeah.
So now my final equation is y equals minus 2/3 x minus 1/3. Now I can say what the gradient is. That is the gradient.
Yeah.
Okay. What do I then do? Oh, this helps to draw a little bit of a sketch so we can understand what's going on. So this here has a negative gradient, and the intercept is minus 1/3. Yeah, where it cuts. So it looks something like this. It's a negative gradient, and it cuts at minus 1/3. That's just a sketch. And that there is minus 1/3. I can work out where it cuts the x-axis as well, simply by making y 0. Yeah, because at this point, the coordinate of y is 0. So 0, if I take 1/3 to the other side, I get that this point here must be at minus 2.
Yeah.
Okay, and this is so this line is parallel to that. So it's going to be somewhere maybe doing that. Oops. And these lines are parallel. So they have the same what if they're parallel?
Same gradient.
Good. So we're told that one of the points here, the x coordinate is p, and we have another point where the y coordinate is p minus 1. The other point, at some stage, we don't know where it is. The x coordinate is 1 minus p, and the y coordinate is 2p.
Yeah.
Now, if I know that the gradient of these lines is minus 2/3, Can I form an equation using these points to find what P is?
Yeah.
Correct, because how do we find gradient? Gradient is found using the formula y2 minus y1 over x2 minus x1. And I've got those points.
Yeah.
X2, y2, x1, y1. And I know what M is. So do you want to have a go at completing the question now?
Yeah.
Good.
Would it be minus the third? Wait, this is not on the list.
Sorry, have we gotten there?
Oh, wait, 1 second, sorry.
No problem.
Oh, the answers I got are are not on the list. I don't know how I got.
That's fine. Let's look at it together. It's okay. So, oops. We're definitely okay with this step here. Yeah. Now we just need to label which one we're going to use as our x2, y1 or whatever. So I'm going to call this x2, y2. I'm going to call this one x1, y1, because I need to use this formula exactly as it is. Yeah. So m is minus 2 over 3 equals to y2 is p minus 1 minus y1, which is minus 2p. And then at the bottom, x2 is p, x1 is 1 minus p. So I can't just write 1 minus p, I need to put that in brackets.
Yeah.
Okay, now if I simplify this, p minus 2p is minus p minus 1 over, if I expand this at the bottom, it's p minus 1 plus p, because that's the minus 1, minus and a minus make a positive. So p plus p is 2p minus 1. So at the bottom, I've got 2p minus 1. So now I have minus p minus 1 over 2p minus 1 is equal to minus 2 over 3. What am I going to do at this stage now? I'll cross multiply. So now I have 3 multiplying to minus p minus 1 and the minus 2 multiplying to 2p minus 1. Can you take it from here now?
Or would it be B?
Would it be B?
Yeah, the answer.
You've just made a bit of an error somewhere. You're gonna have to expand this.
Yeah, I got negative 3p. And then
Very good. So if I come over here, negative 3p minus 3 is equal to minus 2 times 2p is minus 4p. Minus 2 times minus 1 is plus 2. Yeah?
Yeah.
Group the like terms together. This 3 goes to the other side to join the fellow number, and the minus 4p goes to the left-hand side to join the minus 3p. So now I have 4p minus 3p, because it's now positive, is equal to 2 plus 3. 4p minus 3p is p, so p is equal to 5, and the answer is H.
Yeah.
So what did you go wrong here?
I think I don't know. I think I expanded it weirdly. Like, yeah.
Okay, that's fine. We're learning. The whole thing about this is to learn. Okay, we've done that one, yes. That one done. Done that one, done that one. There we go. A rearrangement of sorts.
I got Y, but then I don't know if I got it right. Wait. Yeah.
Have you got anyone that looks like the answers?
I got the white, like I didn't rearrange it because I don't know if I got white right because it's a
Okay.
bit weird.
You can eliminate a few to say this is definitely wrong, but it doesn't really help us because I think it's only one we can eliminate really, because here, which is definitely wrong? Which answer is definitely wrong?
I would say the first one is
Correct,
wrong.
because when this goes that side, it becomes a +5. So this is definitely wrong. There's no doubt about that. But it doesn't help us much because we've still got 1, 2, 3, 4, 5, 6. So sometimes it's always worth to eliminate the one that is definitely wrong. So what you'd said, I'm just trying to follow your steps here. What did you say? Y plus 5 first gives me 3x over 2 minus 1 squared.
Mhm.
You happy with that?
Yeah.
Now, from this point now, we just need to be a bit creative, don't we? So what would the next thing you do from here be?
Mhm.
Any ideas? What would
Wait,
be the
sorry,
next step after this? Sorry?
would you like, I guess you could divide it by 3 on both
That is the
sides.
next step. That is how we do. You're right. So that is what you've been accustomed to. That's the process. Now I have x over 2 minus 1 squared is equal to y plus 5 over 3. What's the next step?
You would square root everything.
You would square root everything. You're right. On both sides. So I'd have x over 2 minus 1 is equal to plus minus, because it's a square root of y plus 5 over 3. What next?
You would plus 1 on both sides.
I would plus 1 on both sides. Okay.
Yeah.
Or in other words, if I wanted to, I can express this as x minus 2 over 2. Do you agree?
Yeah.
Correct. So if I've done it this way, what do I now need to do? What's the next step?
Times everything by 2.
Times everything by 2. You're right. So if I times this thing by 2, in other words, this cross multiplies and goes there, I get x minus 2 equals plus minus 2 y plus 5 over 3. What's the next step?
Take away everything by plus everything by 2.
Sorry?
Plus, so like
Plus
plus
everything. You're right. You're right. So x is equal to 2 plus minus 2. Yeah. Y plus 5 over 3. Which answer is that one?
So 2 plus 2.
It's B, isn't it?
Yeah.
Did you follow that?
Yeah.
Good. Okay, super. Here's another one for you to try. Now, these are common. They like throwing these in your exams. So it's worth knowing how to do these. Again, all this is non-calculator. We want to build some non-calculator capability.
Yeah. Um, I think I'm a bit confused. Yeah.
We're gonna build this one off in a bit of a basic manner. So if I told you something like 2 to the x equals 8, what is x? How do you do that?
So you do square, well, like, I think I know the answer. That's why I don't really.
What's the answer to this one then? What's the value of x?
3.
Very good. Now, how do we work it out? Well, we try and express 8 in terms of a power of 2. So this here is the same as 2 to the power of 3. And because we've got 2's here, for these to be equal, this x must be equal to the 3. You following that?
Yeah.
So the key idea is to try and present everything with the same base number. That's the key thing. That's the trick when you solve these. So here, these numbers should be speaking out a little bit at me. There's a 4, there's an 8, there's a 4. Can I express these in terms of having a base as 2?
Yeah.
Yeah, absolutely. 4 is what? Is 2 squared.
2.
And what's 8?
2 to 3.
2 to the power of 3. Do you reckon you might be able to proceed from there with those hints?
I got 2 to the power of 8 take away 2x equals 4 root 2. That's right.
Okay, so just to look at what you've done here then, we've now rewritten this in terms of these powers of 2. So we've got 2, which is raised to the power of 3 plus 2x, multiplying to 2 to the 2, which represents the 4, and all of this is raised to the power of x, which is then multiplied to 2 to the power of 3, and all of this is raised to the power of minus x. What do you reckon I'm going to do on the other side?
You would. Wait. Would you? Would you divide it all by 2 on the other side?
Nearly there, but the whole thing here, remember, is that we are trying, what are we trying to do? Exercise of the game. We want everything to be in the same base.
Yeah.
So surely don't I want to express this to the same base as well? I do.
Yeah.
Because this is the same as 2 to the power of 2. And what is it multiplied to? How else can I represent this? Square root of 2.
So 2 to the power of, would it be -2?
No, square root of a number is
It's
the
like
same
1 over.
as, how else can you represent a square root? So normally for a square root strictly, we need to write a 2 here.
A half. So 2
Thank you. It's the number raised to the power of half. And a cube root is the number raised to a third. And a fourth root is the number raised to a quarter. So this here, the 4 is multiplied to 2, which is raised to the power of a half. Can you see a way out now?
Yeah.
Go for it.
You then like divide everything by 2 to the power of 2.
No, not quite. At this stage, you now need to use the laws of indices, please. Remember, a to the power of m multiplied by a to the power of n is the same as a m plus n. And then tie it in with this idea that the exponents must be the same on the left hand side. They must be equal to the exponents on the right hand side. Does that give you a bit of a hint?
If I do it on the other side, the x will cancel out though, right?
No. So here now, please note, this a is this 2. These things here are representing the indices, the exponents.
Yeah.
So here I am. So let's remember the other one as well. If I have a to the m, which is then raised to the power of n, which is what I have in this situation. What's the rule for the laws of indices? A to the m raised to the n. What does that give me?
You times it.
Good. So I'm going to use these rules. I'm going to rewrite these down now. So this here is 2 to the power of 3 plus 2x. Now, if I use this law, this is now 2 to the power of 2 times x is 2 to the power of 2x. And this is now 3 times minus x is 2 raised to minus 3x. These two are multiplied together. So this is the same as, I'm going to use this rule, 2 plus a half, 2.5. Now, which rule am I going to use next?
Can you just times it even more on the other side? So 3 plus like
Right.
3.
I'm going to times all of these together, but if I times them, what am I going to do with the laws of indices? I need to add the exponents. So now I have 3 plus 2x plus 2x minus 3x. So 2 to the power of this must be equal to 2 to the power of 2.5.
Yeah.
Can you proceed from there?
Would x be 0.5? So it would be negative 0.5.
Negative 0.5. Job done. So there was a lot of things going on, but I'm hoping you learned a lot from this. So, well, for the main part, at least got a reminder on how else do we express a square root or a cube root, but also a good reminder on how these laws of indices can be useful in evaluating questions like this. Now, in fairness, I've not seen anything as diabolical as this, but I have seen these questions. I was going through, I was preparing one of my students yesterday for a paper 3. There was a paper 3 year 11 exam today at 9 o'clock. And one of the questions that was cropping up in there that we saw in the papers involved manipulating things like this. So it's worth your while getting comfortable with surds and also exponents and the laws of indices. All right. Do you have any questions?
Not really.
How have you found today's session?
It was quite, I guess it was kind of traumatizing, like in some questions like this one, because I get really
Yeah, it
confused.
was quite challenging. It really was quite challenging. I absolutely agree with you. It was quite challenging. But the whole point about it was for you to develop skills. It wasn't even so much so to get to the correct answer. It's so that, you know, we could kind of talk through these different steps. And that way, by you seeing me modeling my thinking around a problem, it helps you understand how to face or how to tackle a problem which is quite challenging. And that's the whole point, because you know you will learn from seeing more examples than anything. Righty. On that note, then, that was very good. Can I unveil a little secret about some of these challenging problems that you've done?
Yes.
These are Cambridge and Oxford admissions tests, but this is the easy section.
Yeah.
Okay, so this is the easy section of the admissions test, the easy section, absolutely. But when do you do those admissions tests? You do them when you are in year 12. Okay, but they're all GCSE, but you only they wait until you do them in year 12 to give you enough practice. But the reason why I'm doing this is because if I can start, or if we can start pushing you onto the capability of that high-end performance, that's what you want. It means your A levels are going to be easier. It means then that you can, you know, you can start looking at top universities. You're not going to be afraid because you've been working at this from a very early stage. There's no point trying to start preparing yourself when you're in year 12 and going, okay, I want to go to a top university now. Let me start doing these problems. It'll be too late. But now you're in year 10. By the time you're in year 11, you will be absolutely flying. By the time you're in year 12, you're going to be like, yeah, bring on those admissions tests because I've been doing them for the last 2 years. Okay. So that's the idea. So don't worry that they're challenging. They are. I'm doing it deliberately. Okay. And to give you a bit of a saying, so imagine the wind was blowing this way and you had a kite. Ever flown a kite before?
Yeah.
You have flown a kite before?
Yeah.
Good. So there's your kite. So our ribbons. Where would you run if you wanted this kite to fly higher? Would you run in the direction with the wind? Imagine the wind is blowing that way. Or would you run in the opposite direction? Absolutely, you run in the opposite direction. So for a kite to fly higher, you have to sometimes go against the wind, which makes it a little bit more challenging because now you're going against the wind. But that is what will make that kite go higher. And that is what we're doing. I'm just using that analogy to let you know that at this point in time, you may not fully appreciate what's happening, but before you know it, you'll be soaring up there and people will be like, wow, you've definitely got greater capability than your average classmates. Okay, so that's what I'm trying to do.
Yeah.
And are you okay with that?
Yeah.
Good. I thought you like a challenge. Excellent. Right, GI. I shall send you this board work. Now, in terms of questions, these questions, these type of complex questions, I would not give you for homework because I think you need me to be, you know, watching over you while you're solving them so that when you get stuck, I can give you a little hint. So I'm by no means going to give you homework questions of this standard. So worry not about that, okay? This is really just something we'll be doing when I can see what you're doing. Would you like any particular practice questions on any particular topic in maths that you fancy I could do with that? I know you've just had your exams, so I don't want to lumber you with a lot of homework. I think it's quite important that you have a bit of a breather, having had exams or your tests recently. So I don't want to lumber you with so much work. I'm seeing you on Wednesday anyway. So
I don't think I'll be able to make it to Wednesday because I got a music trip. So
oh, you've got a music trip. Okay, that's fine. That's fine. So that's fine. So I'll see you then next week on Monday, wouldn't I?
yeah, would you be able to give me like a question based on like shapes, but then with algebra in it? Because I got a question from non-calculator paper on algebra and shapes. I got a bit confused, but I think I got the right answer in the end. So
Yeah,
yeah,
I'll definitely. So you want a question on shapes?
and like with algebra in it as well.
Shapes with algebra. Okay, cool. I'll dig one out for you as just extra practice. Yeah,
Yeah,
and I'll send you the answers as well, so that after you've finished, you can have a look at your answers. Shapes with algebra. Yeah, we'll definitely find some problems there. Cool, super. On that note, I'll say have a lovely evening. Enjoy your music trip on Wednesday as well.
thank you.
Make the most of it. See you next
Thank you.
week. Well
Bye,
done
soon.
today, Jai. Very,
Thank
very good. See you soon
you.
and bye now. Bye.